Hello, my name is Varga, and I'm going to talk about the basic principles of the Arrowhead framework. The Arrowhead framework is built on a system of systems principles, and it features interoperability, integrability, and independence, which I will discuss a little bit further later on. And for example, the interoperability can be reached by addressing the service-oriented architecture approach, which is a very nice feature of Arrowhead. Also, a very interesting feature of Arrowhead is the local automation clouds, which the Arrowhead framework has introduced, and it is also possible to have communication between these local clouds through multi-clouds on the edge, on the platform, or even the enterprise level. To address integrability, Arrowhead introduces various maturity levels, namely 3. Hardware adapters and software adapters can help you in reaching Arrowhead compatibility. The presentation is going to talk about the mandatory and supporting core systems of Arrowhead, as well as collaborations with other Eclipse projects. Now, to get Arrowhead into the perspective of other similar IoT or system of system architectures and platforms, in this picture you could see the comparison of Arrowhead with AutoSAR, with Basics, Fiverr, IoTVT, lightweight machine-to-machine, LWM2M, or OCF platforms or architectures. And you can see that the specifics of Arrowhead is really that it is based on the service-oriented architectures and local automation clouds. It is real-time. It has various runtime features such as dynamic orchestration, authorization monitoring, or automation. It is a distributed platform rather than all the others which are centralized. It is an open source platform. It has high resource accessibility, supported by the Arrowhead Consortia and related partners, which are over 300 by now. The message patterns related to the protocol dialogues could be either request response or publish subscribe. It can be used through any type of transport protocol and practically any type of communication protocols. These are only examples of those, because it can adapt to any third-party legacy systems. It has a naturally built-in authentication, authorization, and accounting, and it is based on standardization features of other standards. 3 main principles of Arrowhead are these. The system of systems of Arrowhead for industrial IoT and cyber-physical systems is really reached by, so the system of system architecture is really reached by interoperability and integrability and independence of these systems within the system of systems. Interoperability is achieved through the service-oriented architecture, for which the 3 main pillars are late binding, loose coupling, and lookup, basically meaning that the consumers and the providers of these services, the services are the information exchange, so the information exchange providers or consumers are not bound or coupled design time, not even deployment time, but they can be dynamically combined, dynamically communicating to each other through this lane binding or loose coupling, and they found each other through the lookup feature of Arrowhead. There is an easy integration between legacy and new native Arrowhead systems through the integrability feature. So if you have a 10-year-old or 20-year-old equipment, it can be still made Arrowhead compliant through hardware or software adapters. And Arrowhead is independent from underlying technologies. Any services can be done with various technologies, and it is independent from application protocols. You can use any protocols and you can translate between them, or Arrowhead provides automatic translation between them. While the IoT world, the Internet of Things world, usually works with global clouds where everybody sends their data up to and it gets analyzed there, Arrowhead has this special feature of local automation clouds where the geographically or security-wise closed systems, so those systems that are either geographically close to each other or they have the same security context or they require similar engineering, they can get into a local cloud which has the same core systems of Arrowhead, and then these local clouds can be communicating with each other. They can exchange services. The application systems of one cloud can get another service from another cloud through inter-cloud service exchange. So based on this local automation clouds principle, Arrowhead achieves real-time operation. It achieves high levels of security, and the engineering complexity is really reduced. How this system of systems approach is addressed in here on the left-hand side. You can see the mandatory core systems of Arrowhead, namely the service registry, where service providers practically register themselves, the orchestrator, where the service consumers ask for orchestration, ask for matchmaking for a given service provider, and authorization and other security features related core system. So these are mandatory for each local cloud, and various application systems that could be service providers or service consumers or both belong to this local cloud, and the services as shown are late bound, loosely coupled, and the lookup feature of the orchestrator provides the service-oriented architecture feeling. On the right-hand side, there are a few supporting core systems. There are many more in Arrowhead, many more, but these are some distinguished ones. So in order for you not to have to develop your own event handlers or translators or gatekeepers and gateways between the local clouds or QoS management or things like that, you can use the Arrowhead provided supporting systems which are available, or you can of course develop your own and you can use that, but Arrowhead has some of these systems and services already available for those who want to use it. For example, for workflow choreography, if you have a production workflow, you can use the workflow choreographer and the executor to help you through that workflow step by step. Dynamically, your system of systems, your equipment in the production area can work with these features. One very key idea is the orchestration, finding a fitting provider for service consumer, and how it works is like the application system on the bottom as a consumer asks the orchestrator to show a proper provider of this service, which it checks the orchestration store, checks the service registry if there are a proper one in there, looks for authorization possibilities with that provider and checks whether the QoS towards that provider is satisfactory for this consumer. And if a provider can be chosen in this local cloud, then the orchestrator sets up the communication for this consumer and the provider, and they then communicate between each other directly. Or the orchestrator can reach out for an external trusted other local cloud through the gatekeeper or other clouds and look for service providers in there in procedures called global service discovery or intercloud negotiations. And this thing can be abstracted to other levels, like not only the production floor level, the edge level, where sensors and actuators are connected to each other with data distributors and algorithms and human-machine interfaces, but their data can get into the IoT platform level, where stream processing happens, or business intelligence dashboard shows the data, or the data gets into the data lake, and then batch processing happens there. And even so, further up there in the Industry 4.0 architecture, you can reach the enterprise level, so this data can reach the enterprise resource planning or the logistics planning systems. Maturity levels of Arrowhead are defined for integrability reasons. So we have the maturity level, the highest level of maturity is maturity level 3, where the native Arrowhead systems can be found. If your system can be made Arrowhead compliant through a software adapter, we call that maturity level 2, or if your system can be compliant to Arrowhead through a hardware adapter, we call that maturity level 1. And of course, in the Arrowhead infrastructure, there are various software and hardware adapters available for various protocols and system types. This is an example of one of such local clouds where various management systems, the core systems, dashboards, algorithms, and sensors and actuators can be found, and they can be orchestrated together, or can they work towards a common goal through the workflow choreography. The supporting core system features are many, but some of these are the translator that allows protocol translation between various application systems, the onboarding controller that handles the new devices coming and onboarding to the local cloud with the support of system registry and device registry, or the choreographer that manages the workflows and executes recipes in a dynamic manner. So the next step is executed depending on the service provider availability, or the PlantDescription, which provides up-to-date information on the engineering plant, or we have the event handler, the QoS Manager, certificate authority, and so on. And we don't only have supporting core systems within Arrowhead, but we have outside Arrowhead as well. These are listed in here. Those are the released ones, the release candidates, and the prototypes, the version 4.13. Actually, Arrowhead is now version 4.2, and we are working on version 5 now. So we are extending the system and service listings in here. And as well as internal to the Arrowhead, we have external systems and projects which we interact with. We have already active interaction with the project on the left-hand side. ForDiac, Vorto, Hogbit, Ditto, Eclipse Ono, Eclipse Paho, Mosquito, or Cuxa. These are all Eclipse projects, as you know, and probably worked with. And on the right-hand side, we have collaboration with involved partners that in the Arrowhead consortia, we have partners that has worked with or developing the Eclipse Capua, Cura, Lishan, Wakama, Keti, or others like Milo, Unide, OM2N basis, and a lot of others. So we are really expanding our collaboration with Eclipse projects. So thank you very much. In brief, this was the Arrowhead framework summary, and hope we can work together in the near future. This was a brief introduction to the Arrowhead framework. Thank you for your attention.